I'm Mr. McBrien. This is TEJ3M, Intro to the Arduino Online. So let's take a step back for a second. If we want to have a computer, a PC, an Apple, an Android computer communicate with the outside world, how does this happen? I'd invite you to pause the movie for a second and think about the answer to this question. How does data come in and how does data go out? Well, if you've given that a little bit of thought, you've probably come up with some ideas like keyboards and mice and maybe the internet. And in terms of output, you probably talked about the monitor for the most part. And if you came up with those ideas, that's great. And that's pretty much true. Now, these may seem like very powerful tools, and they are, but they're not very versatile. So what happens if you want to send out a simple electrical signal, a voltage? What happens if you want to receive a simple voltage to evaluate inside a program that you write? A PC is not well suited to that simple task. So computers, when they work with the outside world, they're carefully defined in terms of inputs and outputs. And it's challenging, certainly not impossible, but it's challenging to have a PC directly control, for example, an alarm system or a robot. In fact, we need systems in between these in order to make those things happen. And in general, simple electrical signals, whether in or out, are not generally possible to use. Now, the Arduino addresses these problems and a whole lot of other problems for us when it comes to writing simple programs to do simple things. All right, so what will we talk about today? We're going to talk about that Arduino. We're going to talk about some example projects that illustrate the amazing things we can do with such a simple device. And we're going to talk briefly about a first sketch we'll build with our TinkerCAD. As well, we'll talk about evaluations and things in the TEJ3M online course. So what's an Arduino? It's an open source microprocessor platform. Open source meaning that it is open to anybody to make modifications to it. It has great versatility in terms of controlling and reading electronic inputs and outputs. It can be programmed using an integrated development environment that is again open source. It can be extended using hardware shields and other electronic components. And it can be connected up via simple pins or other devices that we'll see as the days unfold. So here it is. In fact, it's a very small, lightweight device. Works using 5 volts input. It can be connected up to a power jack. It can be connected up to batteries. And it has a series of pins that might remind you a little bit of a breadboard. And there's no accident there. These input and output pins work just like a breadboard does to connect up to various things. It also has a USB jack that allows it to connect up to a PC or other devices such that you can program it. And there's many other little small components associated with it. So what can we do with an Arduino? In fact, a whole lot. It may not be a hugely powerful processor, but it can do some amazing things. So a few illustrations I found on the web. Here's a secret knock detector that listens for a knock that matches its target pattern and unlocks a door if you achieve that knock pattern. And I've had students implement this, having a safe that opens using a secret knock. Here's a device that connects up to the internet, not a typical implementation for the Arduino, but an effective one. Monitors Twitter, and based on the words that are coming up the most, it actually changes the color of an LED light bulb to match the world's mood. And I invite you to think about what that would seem like in today's interesting news environment. So this is a case where a simple light bulb reflects millions of inputs from the internet. Here's a maybe more traditional self-contained device, but still very interesting. It's an iWriter. It allows you to type on a keyboard using just the motions of your eyes. So how do we set up these kinds of devices? We wire up the Arduino. For semi-permanent devices, we would create our own hardware shield that essentially sits on top of the Arduino, allowing us to make semi-permanent connections. For our more temporary projects we tend to do in class, we'll use our familiar breadboard and connect it up via some jumper wires. Now, many of you won't have an Arduino at home to work with. The good news is TinkerCAD, the tool we've been using to simulate circuits, also supports Arduino programming. So what this means is we can build online virtual circuits and then write our code inside the TinkerCAD interface such that we can do things like have our NeoPixel lights animated, changing colors according to the program that we design. So we can build all these time-resolved programs inside the TinkerCAD website, construct a virtual piece of hardware, and observe our program being executed online. So resources we have available to us. Of course, you're going to have my slides. You have the ARDX booklet that is in Google Classroom. The Arduino website is a tremendous resource with a forum of people who have answered questions and asked questions. Often the things you have asked as a student have been asked many times before and answered by the Arduino community. TinkerCAD is going to be a critical resource for us these days. There's much more if you do a web search. YouTube has considerable help available. How will we be evaluated in this programming unit? Well, in the limited time that we have available to us in the rest of the year, we're going to evaluate two activities. A simple traffic light system that you're going to design, and in keeping with our driving theme, a backup sensor alarm where we're going to evaluate distance to the garage and communicate to the driver what to do. Your submissions will include three components: a movie of your device working, a screen capture that clearly shows the circuit so that it can be evaluated, and your commented code. So your grade will come 50% of it just from the idea that it actually functions, 25% based on the commenting that you do, and 25% based on elegance. How well is it designed to do what it does? So both from a hardware perspective, did you follow the circuit design guidelines that we've been using in the class? And from a programming perspective, how well is the program designed? So your homework for today, please log into TinkerCAD review our activity booklet, and then do the simple blink circuit, blinking the LED. Make a quick modification to the code to make your LED turn off for 250 milliseconds and turn on for 500 milliseconds. And that should be enough for today, certainly. Thank you very much. Have a great night.